Welcome, and now we're going to solve these examples using that Gaussian elimination strategy that's detailed above on our screen. So, if we're going to solve this system, okay, first need to write it in augmented matrix, so that's going to be 3, 2, minus 1, and 1, minus 1, and 4. Okay, now from here, it's a flexible process. What I'm going to do is I'm going to do an arrow to indicate the next stage, and I'm also going to indicate the row operations I'm going to do. First one I'm going to do is I'm going to interchange row 1 and row 2 because I want this upper left entry to be a leading 1. Currently it's a 3. Okay, and if I interchange those rows, then I get a leading 1. So 1, negative 1, and 4, and 3, 2, minus 1. Okay, so now next, I want a leading 1 in this position, right? Because that's going to be row echelon form. So I need to eliminate the 3 and then do something to get that 2 to a 1. But to eliminate the 3, the first thing that comes to mind for me is I'm going to take negative 3 of row 1 and add that to row 2 and put that into row 2. Okay, so every step of the process I'm identifying the row operations that I'm using. So first row remains unchanged. Okay, now this is where this next step, if you need to kind of doodle off on the side to add these two things together, like multiply and then add, you sure can. I'm going to do it in my head. So negative 3 times 1, negative 3 plus 3 is 0. Negative 3 times 1 is 3. Add that to 2, I get 5. And then negative 3 times 4 is negative 12. Negative 12 minus 1 is minus 13. Okay, at this point, I'm almost in row echelon form, but for the next step, and I have to come down here, I need to divide row 1 or row 2 by 5, or equivalently multiply by 1/5. Okay, so then I get 1 minus 1, 4, and then 0, 1, and negative 13/5. Okay, a little ugly, we can work with it. Okay, but now I've done the first and second step, so now I'm going to use back substitution, meaning I'm going to translate it back into a system of equations. So I have y is equal to minus 13 over 5, and then I have x minus y is equal to 4. So then for x in particular, I get x is 4 plus, and then y, which is negative 13 over 5. Now 4 is 20 over 5, so then when I simplify that, I get 7 over 5 positive. Okay, and with this, I've solved the system, and I can state the solution set is 7/5, negative 13/5. Okay, and I'm done. Well, technically I should check my answer, but we're going to go forward because I already checked it. All right, next one. I'm going to repeat this process, but you can imagine here, the first one I got through by using three steps, 3 elementary row operations. Here, probably going to have to do some more because I have 3 equations. Okay, but first, let's begin with writing this as an augmented matrix. So going across by the first row, so 2, 7, 1, 14, 1, 3, minus 1, 2, 1, 7, 12, 45. Okay, now, first thing I'm going to do is interchange rows 1 and 2 because I want a leading 1 in the first row. So I'm going to have 1, 3, minus 1, and 2. And then I'm going to have 2, 7, 1, 14, 1, 7, 12, 45. Okay, now for time and space, I'm going to do 2 row operations at once. I'm going to hopefully knock this out and that out so that I have zeros below that first leading 1. Okay, And so to do that, I'm going to do 2 row 1, negative 2 row 1 plus row 2 into row 2. And I'm going to also take row 1, subtract row 2, or row 3 rather, and put that into row 3. Okay, so first row remains unchanged, 1, 3 minus 1, and 2. And then the second row now becomes, so this is where I have to hold the numbers in my head or write it out. So that'll become 0. 2 times 3, negative 2 times 3 is 6, add 1 is add 7 is 1, negative 2 is positive 3, and then add 1 is 3, and then negative 2 times negative, or 2 times negative 2 is 4, negative 4 plus 14 is 10, okay, and then that's going to eliminate as well when I subtract the 2, so 3, this one's a little bit easier for me, 3 minus 7 is minus 4, and negative 1 minus 12 is minus 13, and then finally 2 minus 45 is minus 43. Okay. Now at this point, this is good. I have a leading one in the first row, I have a leading one in the second row, and they fit that row echelon pattern. Now what I'm going to do is try to knock out this negative 4 because I need a 0 there, and then hopefully that'll give me some information about this minus 13 and make it nice and solvable. Okay, so the next one I'm going to do is I'm going to take 4 row 2 plus row 3 and put that into row 3. All right, so leaving the first 2 rows unchanged. 0, 1, 3, 10, 0, and now here's where the task comes into play. So 4, okay, and then 4 times 3 is 12, 12, okay, 12 minus 12 plus negative 13 is minus 1, and then 4 times that's minus 3, 4 times 10, 40, minus 43 is minus 3. Okay, and now this is not in row echelon form, right? I have that negative in there, so last row operation that I'm going to do here is negative row 3 into row 3. And I get the matrix here, 1, 3, 10, 0, 0, 1, 3. Okay, now this is super nice because with this, I can translate this back. So I'm done with row operations, and I'm going to start that back substitution. So I have z is equal to 3 from the last equation, and then I have y plus 3z is equal to 10, and then I have x plus 3y minus z is equal to 2. Okay, so now I'm going to put this in, and this just gives me that y is 1, and so I have 2 values, and lastly I can find x plus 3 times 1 minus 3 is equal to 2, so I think that just gives me that x is equal to 2. And with this I can say the solution set is, let's see, in order 2, 1, 3. Okay, and now at this point, before I say that, I should really check my answers, and I'll tell you that I took this one out of the book, and that is the answer. But normally you would take each of those values, substitute back in to your equation, and see what you get. Okay, so 2 different examples kind of showing you how we solve using Gaussian elimination. Write the augmented matrix first, do row operations, and then back substitution. Okay, we'll learn about a second method in the next video, but my final comment here is remember that you could have done a different series of steps than I did, and that is okay. If ultimately you got the same answer, I'm okay with it.